Hello student, I am Dr.A.K. Sinha, Professor of Chemistry. Today I am going to discuss efficiency of packing in body-centered cubic structures. Last class I have discussed packing efficiency in HCP and CCP structure. HCP means hexagonal close packing and CCP means cubic close packing. Then last class I have discussed packing efficiency in HCP and CCP structures. Now I am going to discuss efficiency of packing in body-centered cubic structures. Here body-centered cubic structures. Here you have to imagine one cube you imagine, and just you imagine it is a transparent. Cube is transparent and hollow, like that you imagine. Then here you have to consider body centered, means in the center of the cube one particle is there in the center, not on the corners. That you know that in a cube 6 faces are there. Then now you imagine that you can see inside, means just like a transparent, you can see that cube is transparent, you can consider like that. Then in the middle of the cube one particle is there, means one sphere is there, that you consider. Now through this body centered, now you consider that diagonally through body center one you can say diagonal is crossing. One diagonal is crossing through body centered, means one corner of a cube and diagonally other corner of a cube. You consider that in this two corner also a sphere is there, means particle is there. Particle means here atom, ion or molecules may be. Then you consider that one corner and opposite corner, means diagonally via body centered, you can say one diagonal is there. Last class you have considered that face, correct, and there also diagonal you have considered. Now here difference is that you are considering diagonal via body centered, correct. Total 3, here also total 3 spheres can be accommodated. Then in the center, means in the body centered one sphere and other two are in the corner diagonally. Then total 3 spheres are there. Then here only difference is that diagonal is crossing through body, not on face. This is in the crossing this to this all three spheres are diagonally arranged and one is in the center of the cube, that is a body centered. Then now this is a one diagonal including 3 spheres. Here also, like last class, total distance of this diagonal will be In the middle 2 are complete diameter. What is the length of diagonal? Then total length of diagonal will be in the center 2 are means diameter of that sphere plus 1 r upside diagonal upside sphere their radius, only radius, not full, because on that corner I told you it is covering 4 cubes. It contributes to 4 cubes. Then here you can say it is partially. It is not, you can't consider full diameter. It is inside only r you can consider, r. Then one corner sphere r you consider radius, and last corner again r diagonally. Then total distance will be r plus 2r plus r. Total 4r. 4r is the length. 4r is the length of diagonal. Okay, this is very, very important. R plus 2r plus r. Correct? Then total 4r is the length of diagonal. Then now here again important things you have to understand, that here again you will consider one triangle. One triangle you have to consider. But here what you will find that because it is body centered. Then diagonal is through body. Hence here base, what base you will consider? That is the new things. You have to think seriously that what will be the base. Base will be not the side. Base will be not the side of the cube. Correct? It will be not the side. Then what will be? Then here again base will be just you can say consider that will be also a diagonal. In the just you can below cube is there, then I am talking about the down 4 corners are there. Then from that out of that 4 corners, now you consider that corner. Which corner you will consider? Then that corner from which diagonal pass through body centered. That corner you have to consider. Then now you consider, then from that corner diagonally again you are considering one diagonal. From that corner only one diagonal you have to consider. Correct? Then here 2 diagonal you are considering. One through the body center, and to make a triangle one base is required. Then for that base that down of the cube 4 corners are there. Then the corners from which you can say diagonal pass through the body center, that corner you have to consider down, and from that down corner you have to consider one diagonal. Correct? Then now you will get one triangle. Then triangle name you can consider. Actually in the cube you can write in an ordinary cube you can write cube A, B, C, D, E, F, G, H. Correct? in a cube, 6 corners are 6 corner will get 4 into 2, 8 corners are there, 6 sides and 8 corners, 4 up, 4 down. Then you can just give naming each corner A, B, C, D. After that, you can write E, F, G, H. Correct? Total 8. Then here you will find one triangle you have to consider. One triangle you will consider. Then you will find a triangle. Now it is ready. AFD. One triangle will be formed. AFD, right angle triangle. Because you know that if diagonal is involved, then right angle triangle will be formed, just like last class. But here only thing is that base is not the side. In that time base was side. Here base is not the side. Diagonal is the base. Diagonal is the base. Hence in this triangle two bases are, in this triangle two diagonals are there. One is H, hypotenuse, and base is again diagonal, and perpendicular, that is the only one side is perpendicular. One side is perpendicular and two diagonal is there. One diagonal is considered as a hypotenuse and other diagonal you consider as a base. Then now you have to calculate, you have to know the diagonal length. Diagonal length, both diagonal length you have to know. Then one diagonal length already you have calculated. Its value is 4r. 4r. Then now what will be the value for you can say base? Base diagonal, what is its value? You have to calculate first. Then after that same things what you have done in the previous class. Then what will be the value for the base? Base you consider as a B. Base you consider as a B, a small b. And first diagonal hypotenuse you consider as a C, but that C is equal to 4r. That C is actually equal to H, hypotenuse. Hypotenuse is C, correct? And that value is 4r, equal to 4r. But base, what will be the value for base diagonal of this triangle? Then triangle actually we are considering to get the value of B, to get the value of the base diagonal value, to calculate that we are considering one more triangle, that is the right hand side, you can say, that is this is the just like a triangle, right hand side. Okay. Then here in this triangle, right angle triangle is there. Then you know that right angle triangle, that one hypotenuse will be there and two sides will be perpendicular to each other. That you know. Two sides will be perpendicular to each other and that diagonal will be hypotenuse. Okay, means below down the cube, that corner you are considered one diagonal, that is actually H, that is actually hypotenuse for this triangle, new triangle. That name you will get automatically EFD. EFD, that is right angle triangle. Okay, right angle triangle, that is the two sides are there and one diagonal is there. And that diagonal value you want to know. Now in this case you know, because two sides are involved, then in cube all sides are equal. All sides are equal. A small a you can consider as a small a. Then now very easily you can calculate then this diagonal you have considered simply B. Okay, then B square means diagonal square is equal to perpendicular, this perpendicular square means length square. Triangle three sides are there. The one is diagonal, that is a hypotenuse. Then h square plus p square plus b square, that formula you know. Then here you can say h square is equal to p square plus b square formula, base square, perpendicular square plus base square. Here perpendicular and base both are same, means a square plus a square. It means in this case hypotenuse square means h square is equal to a square plus a square, that is a 2a square. Then h is equal to under root 2a square, means under root 2 into a. Then that is the, you can say h value means b value. That down base what you wanted to calculate, that value h is equal to under root 2r, that is the base b you have considered, that b is equal to, that is the base diagonal, its value you can calculated under root 2r, under root 2a. Okay, this is the value of base. Then now that triangle, main triangle you have considered. Now you got in that triangle two diagonal was involved. Then down means base diagonal, its value is root 2a, under root 2a, outside a. This is the value for base, correct? And now other diagonal value you are knowing, that is that h value is the 4r. Then now this main triangle what you are considering, in that length is a, because one side is involved, correct? That one side is involved, then its value is a centimeter, a, and hypotenuse value is 4r. 4r means h value is equal to 4r, and base you have considered now calculated under root 2a. Then now all three sides you are knowing, then formula again second time for this angle, that is the triangle. You can, if you will see that diagram, then automatically you will understand that triangle is AFD. Then here hypotenuse, main triangle hypotenuse, that you can consider diagonal as a C also, C, correct? C or H, anything you can consider. Then hypotenuse is equal to P square plus B square, means perpendicular square plus base square. Formula is there. H square is equal to P square plus B square. Then now H square is equal to P square plus B square. Then here P square means side A square, P square means A square, and B means base. Then base you have considered already calculated, under root 2a. Then now it became a square plus under root 2 into a whole square. Then what you will get after solving it? A square plus under root 2 into a. It means 2a square. Then a square plus 2a square. Total 3a square. 3a square you got. It means h square is equal to 3a square. H square is equal to 3a square. H square you can tell c square also. C square is equal to 3a square. Means h square, hypotenuse square is equal to h square is equal to, or c is equal to c square. Both are same. Then h square is equal to 3a square. Then h is equal to what? Under root 3a. Under root 3a. Correct? It means this hypotenuse is a c. C you have given the name. Then c is equal to under root 3a square. 3a square. Then now see, all value you are knowing. All value you are knowing. Correct? Hypotenuse value you have calculated 3a square. But that hypotenuse you know that is equal to 4r. That hypotenuse value you have calculated as a 4r in the beginning. 4r means this 4r, h is equal to under root 3a, but this h is equal to 4r. In the beginning we have calculated. Then this 4r is equal to under root 3a. Then now, like last class, here again you can get the value of a also and r also. Then because under root 3a is equal to 4r, then a is equal to 4r divided by root 3. Correct? That is the value of a in terms of r. Now from the same equation you can get the value of r also, because under root 3a is equal to 4r. Then r is equal to under root 3a divided by 4 in term of a. Then only from one equation you got value for both. By using this equation only, under root 3a is equal to 4r, you got the value of a and r. Correct? Both value got. Value of a also and value of r also. Okay. A in terms of r and r in terms of a. You got the value. After that, like last class, same concept is the same. Here, in this type of structure, you are considering body-centered cubic structure you are considering. Then in this type of structure, total number of atom is 2. Only 2 atoms can be fully accommodated. Fully. Only 2 sphere. Fully. Okay. Then here, that is a 2 sphere only you have to consider. Means 2 atoms. And then what will be the total volume? In the first case you have seen 4 sphere was accommodated, but here only 2 sphere is accommodated. Then here total volume will be 2 into volume of a sphere, 2 into volume of a sphere. Then a sphere volume 4/3 pi r cube. 4/3 pi r cube. Okay. Then only here you can write, you multiply by 2. Then 2 into 4/3 pi r cube. This is the total volume. Okay. This is the volume of due to the 2 spheres. Volume of 2 spheres. Okay. Then now what will be the volume of the cube? Then cube volume a cube. Volume of the cube means a cube, because a is the length of the side. Okay, a cube. Then now here a value a value already calculated. A is equal to 4r divided by root 3. You have calculated. Then a cube means what? This 4r divided by under root 3. Then it's a 3 power cube. 4r divided by root 3 and power 3. That is the volume. Okay, whole cube you can write 4r divided by root 3 power 3. That is the actually volume of the cube. Volume of the cube. A cube is equal to 4r divided by under root 3 power 3. Okay. Then this is the volume of the cube you are knowing. Then nothing is there, 2 volume you are knowing, volume of the spheres you are knowing, total volume of the spheres, and volume of the cube you are knowing. Then like last class, packing efficiency, you know, packing efficiency is equal to volume occupied by 2 spheres. There was 4 spheres last class, that in case of HCP or CCP, here 2 spheres. Then packing efficiency is equal to volume occupied by 2 spheres in the unit cell into 100 divided by total volume of the unit cell. Total volume of the unit cell. Then already know these 2 volume you are knowing. Volume occupied by 2 spheres already you have calculated. That is the 2 into 4 by 3 pi r cube. Okay. Into 100 and down total volume you have calculated, total volume of the unit cell. Then that is the here R value. R, what is the value of R? Here total volume of the unit cell you have calculated. Then here R is equal to root under root 3 divided by 4a. 4a. Then for 2 sphere, that already calculated for 2 spheres. Volume of the cube I am talking about. Total volume of the unit cell AQ. AQ value now you write here. Then here it will be 4 divided by under root 3 into R. R is small r, is upside. Correct? Then this is the actually total volume of unit cell. Because volume of the cube, AQ, you want to know, A value you are knowing. 4 by 3, 4 divided by under root 3 into R, power 3. That value you keep here. Then after solving it means volume occupied by the 2 sphere. That volume you have written, and down you have written total volume of the unit cell. That is the 4 divided by under root 3 into R. R is with 4, power 3. Both value you have kept and you have multiplied by 100 because you want to calculate in percentage. Then after solving, its value will come 68%. 68%. Last class value was 24% in case of HCP or CCP. Now its value is 68% less. Okay, this I have discussed efficiency of packing in body centered cubic structure. Okay, now next I am going to discuss, that is the packing efficiency in simple cubic lattice. In simple cubic lattice, here all things are what we have discussed in last class and today. Then all concept is same, only a structure will change, little structure, minor change in structure. It is again further easy. In comparison to these two, it is easy. Here in a simple cubic lattice, the atoms are located only on the corners of the cube. You know all the things. In a simple cubic lattice, the atoms are located only on the corners of the cube. Means 4 up, 4 down. Total 8 corners are there in a cube. The particles touch each other along the edge. If you put only you consider one edge you consider, only one edge. Okay, means 2 corner. If you put one sphere, then both sphere will touch to each other. Okay, both sphere will touch to each other. Only 2 sphere you are keeping. One corner, one sphere, other corner, other corner other sphere. Only two spheres are there. Then if you will keep two sphere, means two atoms, then you will find that both spheres are touching. Both spheres are touching. Correct? Then this is here important point, that two spheres if you will keep in the two corners, means one edge, then both will touch. Both will touch. Means here side you can consider as a 2R. 1R from one R from one sphere and 1R from the other sphere. Then that is equal to 2R. And this 2R is equal to A. A means side of cube. Side of cube. A is equal to small a is equal to 2R. Small a is equal to 2R. Correct? Important things. This is very, very important in this derivation. Okay. R, you know, that is the radius of a sphere. Actually, every sphere, if it is in the corner, then it will cover 4 spheres. Because now in a practical way, we will think that one sphere is kept on only one cube corner, then you will find 1/4 is only in one cube, and other 3 parts will cover other 3 cube. Other 3 cube it will cover, and one part will remain only with one cube, only 1/4. That is because that is at center. Say sphere is on the center. On the you can say corner. On the corner is just like a center of a sphere. Center of a sphere, that is on the corner. Then obviously only 1R, only radius will involve in that cube. In all other 3 cubes, total 4 cube, every cube R only you can consider. Okay. But here, that because 2 sphere you have kept, then R of the first and R of the second, total R plus R, 2R, that is equal to A. A means here length of the cube, base of the cube, one side of the cube, that is equal to 2R. The volume of the cubic, and it's then if now you are knowing the value of A, and A is equal to 2R, then what will be its volume? Volume of the cube, volume of the cubic unit cell is equal to A cube. A cube is equal to 2R power 3. 2R power 3 means 8R cube. 8R cube, that is the volume of the cubic unit cell, means 1 cube. Since a simple cubic unit cell contains only one atom. Here you have seen that in the first case HCP or CCP, 4 cubes were accommodated, and now today I discuss in body centered only. In body center only two you can say cubes were accommodating. But here in a cubic lattice only one sphere will be accommodated. Only one sphere. 1/4 each. Then it will become what? Only 1/4 each corner. Correct? Then it will become like a 1/4 plus 1/4 plus 1/4, half plus half, 1. Then there will be, you will think that there are 4 parts of a cube are involved. That means just like one sphere, 4 spheres. 1/4, 1/4, 1/4, 4 1/4. Then 4 into 1/4, that is the 1. But body center you have seen, one was in the complete sphere was in the middle. Again 1/4 and this half was there. Then that's why here this thing total 2 was there. One was in the center, and half was there, corner. Means total that was, if you will see the sphere in real cube, then you find in body center only 2 can be accommodated, fully accommodated only 2. And HCP or CCP 4 can be accommodated. But in this case, simple cubic lattice, only 1 can be accommodated. Then the volume of the occupied space will be what? Only 1 cube is there. In 1 cube, only 1 sphere is there. Then what is the volume of 1 sphere? Every time you have calculated the volume of a spheres plus volume of the cube. Every time you have considered, correct? But the sides you were calculating, you were determining side value A in all cases. Here also you are going to calculate A. What is the value of A? Then A value you know. A is equal to 2R. Then what is the volume of cube? Then volume of cube will be here. One you have considered the volume of the cubic unit, that is the AQ, that is the 2R power 3 means 8R cube, first volume. Okay, that is the cubic volume. And second, a sphere volume will consider the volume of the occupied space or a sphere 1, that is a 4 by 3 pi r cube. 4 by 3 pi r cube. You have to multiply it only by 1 because only 1 sphere is there. 1 into 4 by 3 pi r cube. Then these 2 volume again you will utilize in where? In efficiency formula. Packing efficiency formula, these 2 volume you will keep there. Okay. Then here packing efficiency is equal to, like other 2, here also volume of 1 atom. Volume of 1 atom means volume of 1 sphere divided by volume of cubic unit cell, and upside multiply by 100. 100 because you want to know value in percentage. Then packing efficiency is equal to volume of 1 sphere or 1 atom you can tell into 100 divided by volume of cubic unit cell. Correct? Then after putting this 2 value, that is equal to 4 by 3 pi r cube divided by 8 r cube. 8 r cube already calculated. Then into 100, upside 100. After solving, result will come 52.4%. 52.4%. Then see, 3 you have considered. In case of HCP or CCP, it was 74%. In body centered, it was 68%. 68%. And now you got 52%, 52.4%. Then what conclusion you will draw from these 3 values? Then thus we may conclude that CCP and HCP structure have maximum packing efficiency. CCP or HCP structure have maximum packing efficiency means 74%. Question is asked in every examination, medical, engineering, other exam also. Okay. Then this 3 I have discussed. Now fourth one I am going to discuss. Fourth one is actually it is not efficiency. Okay, it is not efficiency. This is the calculation involving unit cell dimensions. This is a different, but it is also mathematical. Okay, that is a calculation involving unit cell dimensions. Unit cell dimension, here dimension means length, breadth, height, that you will try to know of any cell. Okay, of any cell, that any unit cell, you know that the unit cell may be of different type. Unit cell may be of different type, that you know. Only one unit, whatever with the type, structure, whatever with the structure. Okay, only one unit, that is repeating, that structure, only one unit you are always considering. Then here, what type of unit cell is there, that you don't know. But if you want to know any type, you want to know what is the length, what is the breadth, what is the height, what is density, correct? If a unit cell is there, then what is the, you can say, total density of this unit cell. Density is equal to mass by volume, you know. Then you can for any cell, any unit cell, you are interested to know the what is the volume of the unit cell, what is its mass. When you are knowing volume, you are knowing, and mass you are knowing, then density you can know. Density is equal to mass by volume. Okay, density is equal to mass by volume, m by v, per unit volume. What is the mass? That is actually density. Okay, per unit volume, what is the mass? Exactly, it is mass per unit volume, that is called density. Then here you will try to know the all three, because all things are related to the, you can say, cube volume. Cube volume we will come to know. Length, their length, breadth, height you can know, correct? Density you can know, hence their dimension you can know. Dimension, length, breadth, height you can calculate. Okay, then this is related to that only. That's why it is called calculation involving unit cell dimensions. Then this is also easy only. Only thing is that you should understand. Anything if you understand, even the very difficult things also, very difficult, if you will understand, that things will be easy. And easy things also, if you are not understanding, then that will become tough. That will become tough. There is no tough like this. There is no word, you can say, in science. Toughness, it depends on you. If you are understanding, then no toughness, easy only. If you will not understand, then easy things also will be tough. Okay, this point is very important. I told you, nothing is difficult. Nothing is tough. It depends on you, whether you have understood or not. Okay, hence, now three things I have discussed. Now because I think you have understood, that's why it will be easy for you. Now here also little different is there, but it is also easy, provided you should understand it. Okay, now I am going to discuss. From the unit cell dimension, it is possible to calculate the volume of the unit cell. From the unit cell dimension, means length, breadth, height, it is possible to calculate the volume of the unit cell. Knowing the density of the metal, density of the metal is generally fixed, always to be fixed. Knowing the density of the metal, we can calculate the mass of the atoms. Mass of the atoms, not atom, only one atom. Atoms in the unit cell. If you are knowing the density of the metal, knowing the density of the metal, we can calculate the mass of the atoms in the unit cells. Why? Because density you are knowing and volume you can calculate. Volume you can calculate, length into breadth into height. Then if density and volume you are knowing, then easily mass you can calculate, because D is equal to m upon v. Out of 3, 2 things you are knowing. Then third thing you can calculate, means volume you are knowing, density you are knowing, then mass easily you can calculate. The determination of mass of a single atom, the determination of the mass of a single atom gives an accurate, you can say, method of determination of Avogadro constant. If you are knowing mass of one atom, then Avogadro number you can calculate constant. Correct? It can give correct, you can say this Avogadro constant value you can calculate. Okay. By knowing single atoms mass, then an accurate method of determination of Avogadro constant. Okay. Means determination of the mass of a single atom gives an accurate method of determining of Avogadro constant. This is again important things, because one value you are knowing, mass of one atom you are knowing, the Avogadro number 6.02 into 10 to the power 23 particles. Then you can calculate very easily this value. Then now again just come to the important point. Suppose age length of a unit cell of a cubic crystal determined by X-ray diffraction. Generally by this method, X-ray diffraction method, small things you can measure, very small. Then suppose age length of a unit cell of a cubic crystal determined by X-ray diffraction is D is actually density of the solid substance, and m the molar mass. This you have to consider. Okay, means age length of a unit cell of a cubic crystal determined by X-ray diffraction is A. Suppose it is length is A centimeter, you calculated by X-ray. Okay, and density also D can calculate, and density of the solid substance, and capital M, that is the molar mass. Okay, suppose this can be determined by X-ray diffraction method. Okay, then now here calculation is there. If age you are knowing, means one side you are knowing, then obviously volume will come to know. Volume of the unit cell will be AQ. First important things. Now mass of the unit cell. Mass of the unit cell, how will you calculate? M. Capital M, mass of the unit cell, how will you calculate? Then that is equal to number of atoms in unit cell into mass of each atom. Mass of each atom. One atom, if you are knowing mass of one atom you are knowing, then in one cubic center, suppose 1000 atoms are there. 1000 atoms are there. Then A into 1000, a small m, suppose it is the mass of one atom. But in a cube many atoms may be there, 1000, 10,000, 20,000 like that. Then what is the total mass? Total mass of the unit cell. Then if suppose it is 1000, then 1000 into a small m. that is actually capital M, molar mass. Molar mass. Mass of one atom into 1000 in one can say cube. Suppose unit cell 1000 were there or 10,000 were there, then 10,000 into a small m. That is called, that big mass is called molar mass, capital M. Okay. Then here mass of the unit cell capital M is equal to number of atoms in unit cell into mass of each atom. Mass of each atom means Z into M. I told you 1000, 10,000, but you don't know exactly how many atoms are present in one cube. Z you can consider. Z atoms are present. Then Z into M, small m. Small m is the mass of one atom. Then capital M, molar mass, is equal to Z into M. Okay, here already told you Z is the number of atoms present in one unit cell, and a small m is the mass of a single atom. Then mass of an atom present in the unit cell, that also you can calculate. Now here is the based on formula. These things what I am discussing now, all things are based on calculation, formula based. Now I told you molar mass, capital M, that is suppose many small atoms are there in a cube, then total mass you are knowing M, that is a molar mass, and you want to know mass of one atom. Small atoms are there, many atoms are there, suppose all atoms are same, then what is the mass of one atom, that also you can calculate if you are knowing the value of M. Then here how will you come to know? Then mass of an atom present in the unit cell, that is a small m, is equal to capital M divided by Avogadro number. N, capital N A means Avogadro, capital N A, Avogadro number, symbol is there, N A. Then now we will ask why, what is the role of here N A, Avogadro number? Then here you should know, already I have discussed in the previous classes in the beginning only, that Avogadro number is equal to 1 mole. Mole concept, that time only I have discussed. 3 concept I have discussed. Okay, there are actually 4. Then first concept I will discuss, if you can say any substance are existing in the gaseous form, many atoms will be there in gas, then that time this volume at STP is equal to 1 mole. Volume at standard temperature and pressure, that volume is equal to 1 mole. That is the one relation. Okay, volume at means that volume is actually 22.4 liter or 22,400 ml. In case of gas, 22.4 liter or 22,400 ml at standard temperature and pressure, that is equal to 1 mole. Means 22.4 liter is equal to 1 mole, or 22,400 ml is equal to 1 mole. This is the one concept, 1 mole. Second concept, 1 mole is equal to molecular mass. The second concept, 1 mole is equal to molecular mass. Okay, if it is a weight, in the term of weight, molecular mass is equal to 1 mole. And third concept I have told you, that If it is in term of number, then Avogadro number is equal to 1 mole. Avogadro number is equal to 1 mole. Then the main concept is there. Means molecular mass is equal to 1 mole. Okay. And 22.4 liter is equal to 1 mole. And Avogadro number is equal to 1 mole. Avogadro number means 6.02 into 10 to the power 23 particles. Particles may be atom, may be ion, may be molecules. Okay, anything in this number, that is called 1 mole. Fourth, I told you, that is the atomic mass is equal to also 1 mole. Atomic mass is equal to also 1 mole. Then here Na, N is the Avogadro number. Then it is a big number, 6.02 into 10 to the power 23 particles. That's why if you are knowing total mass, cubic mass means cubic cell, their mass you are knowing, capital M, then that mass includes a large number of atoms, that you are considering here Avogadro number, because M is the molecular mass, and molecular mass is equal to Avogadro number. Avogadro number is a big number. Then that you have divided. Then you will get mass of one atom. Means capital M divided by Avogadro number, that is equal to mass of one atom. That is equal to a small m. Then a small m is equal to capital M divided by Avogadro number. Avogadro number is represented by Na. Okay. Then now you got the value of, if you are knowing the molecular mass and Avogadro number is fixed, always it is fixed. Okay. Then 1 m value means value of one atom you can get, means m, small m value easily you will come to know. Okay. Then after that, when a small m value you are knowing, capital M value you are knowing, and Avogadro number value you are knowing, then what is the problem in calculating the density of the unit cell? Very easily. Density is equal to mass by volume. Mass of the unit cell means capital M. Mass of the unit cell means capital M divided by volume of the unit cell. Volume of the unit cell. Then volume of the unit cell also you are knowing. Easily you can calculate. Then mass of the unit cell, how will calculate? Mass of the unit cell, how will you calculate? Then if you are knowing mass of one atom you are knowing, that is a small m, and suppose in that cubic cell z number of atoms are there, z number, then z into m, that is the capital M, that is the molar mass, means cubic mass of a cube. Then that value, density, mass by volume. Then mass you have calculated, mass of unit cell means z into m, and divided by volume. Then volume AQ. Then if you are knowing the side, you can calculate the volume. Then here you have written z into m divided by AQ. This is the main. Density is equal to mass by volume. Then here mass is equal to a small z into a small m. Z means a number of atoms present in a cube. Z into m divided by AQ. Then if you want to put the value of a small m value you put, then how? Then capital M divided by N. Capital M, molecular mass divided by Avogadro number. Capital M divided by N, that is the small m. That value you put here in the place of a small m. Then you will get Z into capital M divided by AQ into N. Down N will come, because m is equal to a small m is equal to capital M divided by n. Then m value you have put here. Then it became Zm, Z into m divided by AQ into capital N, Avogadro number. Then this is a density. You got the value of density. Means D is equal to Z into capital M divided by AQ into N. Na means Avogadro number. This relation is very, very important. Okay, because here total how many things are there? Then D is there. D is equal to Zm. Then Z and M 2 terms. And down AQ 3 and N. Total 4 terms. And including D it is a 5 terms are there. D is equal to Zm divided by AQN. Total 5 are there. If out of 5, 4 you are knowing, then 5th you can calculate. Okay. If out of 5, 4 you are knowing, then 5th you can calculate very easily. Okay. Then here one thing you have to remember, density of the unit cell. Density of the unit cell is the same as density of the unit cell. We are talking about a big unit cell. Density of the unit cell is the same as the density of a substance. Density of a substance and density of the unit cell both are same. During solving the numericals, this concept you have to use, that density of the unit cell is the same as the density of the given substance. The density of the solid can always be determined. Already I told you, density of the solid substance can be determined by other methods. Many methods are there. Out of the 5 parameters, that is the D, Z, M, A and N. If any 4 are known, we can determine the 5th. Then now I have discussed all things, all calculation of this chapter. Now a few numericals are there. It will take more time. Today it is not possible. Then 4 numericals I will discuss on this concept, which is asked in all examination, medical, IIT, everywhere in all examination, even in Csir-Net also, based on this concept, question is asked. Okay. Actually, concept is used everywhere. Csir-Net is the toughest examination. Then here also they will ask question based on this concept they will use. Problem will be different. Problems will be different, but without these concepts, they can't solve. But numericals will be different, all problem will be different. But concept is useful. Okay. Then this type of question is asked everywhere. Even in sometimes easy question they will ask in UPSC exam. Easy question, but concept will be the same. Okay, in UPSC question will be easy only, but number of question will be more. Not very tough question. Toughest question is asked at Csir-Net. Okay, and IIT also tough question they will ask in advanced level. Okay, then this numericals I will solve in the next class. Today I am stopping only here. Thank you.